Yeah, that's always a good idea. Okay, so I'm not focusing a lot on ARMA processes. Just I'm describing small small points that should be clarified. That equation is not a process. Even if lambda is greater than 1, you have one stationary equation of an equation. You have one stationary solution of an equation, but this solution looks into the future. And if you'd like to avoid solutions that look into the future, then you can say about lambdas less than 1 by absolute value. Okay, what is Arma Pq process? I will provide an example of something like Arma, let's say 2-1 equation. Yeah, 2-1 equation. I have introduced lag operator, so I may speak about general. It's something like A of L times YT equals to B of L times UT. UT is a white noise, and we assume that there are AL is of degree, is a polynomial of degree P. B of L is a polynomial of degree Q, and A of L and B of L equation. So first I specify equation. A of L and B of L has no roots in common, has no common roots. So that is a specification of equation. Why I have this condition that AL and BL has no common roots? Why it's important to avoid common roots in equations A of L and B of L? To illustrate
so that for them not to cross out.
Yes, and why we have
because it will reduce our P and Q parameters.
And why we fear that? The main point. Yes, you are telling good statements, but why?
Maybe if they have a common root, then we will not be able to uniquely define, like as we did before. It would like group up into the same coefficient, like epsilon and YT.
In some sense, you are right. If we have similar roots, we may have infinite number of stationary solutions. Yeah, in some ways you are right. Probably it's one of the reasons, but the main reason is that we'd like to have a simplest description of our process. We would like to have the most simple description, and if we'd like to have most simple description, but in some ways you are right. For example, if I have an equation like that, yt is yt minus 1 plus ut minus 1, then this equation has this equation is very special. It has infinite number of non-stationary solutions, and it has infinite number of stationary solutions. So you may check that if I consider yt, that is 5 plus ut, it's a solution of this equation. If you check that yt is 6 plus ut, it's also the solution of this equation. And we would like to have the simplest description on non-ambiguous. Yes, you are right. We'd like to have the simplest and non-ambiguous description of a process by equation. And this theorem we have stated previously. It says that we have no ambiguity when lambda is not equal to 1 even, because when I write an equation of ARP type and I say I'm considering a stationary solution of this equation, then I have no ambiguity because there is only one solution. And if I have common roots, it may happen that I have infinite number of stationary solutions of the same equation. Yes, basically you are right. We'd like to have unique, simplest, unambiguous description of a random process. Okay, so this is Arma equation, and we have Arma process. So I will define Arma Pq process as obviously a solution of Arma Pq equation with two additional requirements. Requirement one is that solution is stationarity, and the second requirement exactly the same, that yt. So I have Arma Pq equation that A of L yt equals to B of L ut, and yt depends only on ut, ut minus 1, ut minus 2, and so on. But you should know that Arma equation sometimes may have a stationary solution that depends on future ut plus 1, ut plus 2, or may have a stationary solution that depends on both past and future values of u, on ut minus 1, on ut plus 1, on ut minus 2, on ut plus 2, and so on. And these solutions may be useful for reconstructing for missing values. So do not forget this point, because otherwise, if you start just to identify equation is a process is equation, then you will probably you will not miss anything important if you are just doing short-term forecast. But this theoretical difference between an equation and a solution is worth knowing to get deeper understanding of time series models. Okay, let's move on. Once again, we have no interpretation for Arma Pq coefficient. If I have something like yt minus 0.5, yt minus 1 equals to ut plus 0.3, ut minus 1, and once again, I consider stationary solution, and yt depends only ut plus ut minus 1 plus, and so on. So I have an equation plus two hidden assumptions. So usually in many textbooks, these two hidden assumptions are ignored. I'm not only writing an equation, but I write either I should completely, so how I may specify an equation. Either I should write a solution. I may write an equation and the initial condition, or according to this theorem, I can write an equation and state that I need a stationary solution that does not look into the future. So either two ways. Either I have initial condition, either I have two implicit descriptions, and then we are speaking about the same solution of one equation. Okay, and what is now we may define a ARIMA PDQ process. That is just we say that yt is a ARIMA PDQ process if delta to the power d of yt is Arma Pq process. Because we have defined Arma Pq process as a stationary, non-looking into the future solution of Arma Pq equation, and Arma Pq equation excludes the same common factor in left-hand side and right-hand side. And finally, I may briefly describe. So that's enough to model seasonality. Okay, we may model seasonality if I say that if I have monthly data. So what about seasonality? What about seasonality? I may always model YT, like if I say YT is autoregressive process with, let's say, of order 13, that will model seasonality. So this process will predict seasonal effects. That's a bad model because it has too many parameters. But if you have a very, very long stationary time series, that is okay. But that's not parsimonious model. It has a lot of parameters inside. So to avoid this excessive parameterization, we introduce seasonal. So that's okay. This model will predict seasonal effect. This model will predict seasonal effects. But that's a bad model because it has too many parameters. Okay, what about seasonal ARIMA processes? We basically use the same thing. We use just less parameters. So seasonal ARIMA process is a particular case of Arma Pq process. But just we need to it may be seasonally integrated, not completely. There is a subtle difference. We may have seasonally integrated processes. Yeah. Okay, what is seasonal ARIMA process? Once again, I need to define a. I will provide rigorous definitions because they are rare in popular books on time series. So I will spend a little of time and provide honest definitions. So first I start with seasonal Arma equation. So I have Arma that has P, Q, and big P, big Q. So I have non-seasonal. These are non-seasonal number of parameters. And these are seasonal polynomials. So I have an equation of type A of L times A seasonal of L to the power 12. So I'm speaking about monthly data, but if you are speaking about quarterly data or B monthly data, then you guess how to change L to the power of 12 times YT equals to B of L times B seasonal of L to the power 12 times UT. So this is a seasonal Arma equation. And once again, I require that A of L times A seasonal of L12 and B of L, B seasonal of L12 has no common roots. So I require equation. I have the requirement that I have no common roots. So AL is a power P, seasonal L, A of T, A of some, let's introduce artificial variable. Artificial variable. It is a bad idea. Of W. Of W has this is a polynomial. This is power. This is order of polynomial. Order P. Seasonal has order big P. B of W has order small p. This is big P. This is small q, and seasonal has order big Q. So this is polynomial, and this is order of polynomial. So maybe I should wait a little bit here. Everything is fine here. I will provide an example in a moment. Okay, everything is fine?
I have a question.
Yeah,
So
yeah.
capital P and capital Q are represented as integers, or is the set of integers?
No, integers, 12, 10, 1, 2. I will provide an example in a moment. Maybe it's better to just one moment.
Okay.
I will check.
Sure, then I'll wait for the example.
Just a moment. I'm searching for a where it is. Just a moment. I'm searching for for orbit model by Uber. I will find the process I have compared with. Where is the article? Just a moment. I'm searching for Uber model and it, yeah, probabilistic forecasting exponential. Just a moment. It's published on Archive, and I think that's the most useful example of ARIMA model. I think that's the best, the default one when you need when you have 5 seconds to decide which model should you estimate when you speak about seasonal ARIMA model. Yeah, okay. So I will just say that Arma seasonal Arma process is obviously a solution of, maybe it's boring, but that's the only way to be rigorous. Seasonal Arma process is a solution of seasonal Arma PQ big P big Q equation with 2 properties, that is stationary, and YT depends on UT minus 1. And finally, I'm able to say what is a seasonal ARIMA. PDQ big seasonal P, big seasonal D, big seasonal Q process. We say that YT is a seasonal ARIMA if delta to the power D times delta seasonal to the power big D of YT is seasonal Arma PQ big P big Q process. And now some examples. Let's start with, I think, the most important one. So if you have, let's say, 5 seconds to decide, I have a seasonal monthly time series, which ARIMA should I use? You should use, so this is one model that is basically like, it's not always the best, but that's a very good default candidate for modeling. So if you have no automatic selection procedure, and even if you have automatic selection procedure, because every automatic selection procedure may be wrong. So one model to start with, is seasonal ARIMA 111100. That is seasonal, that is non-seasonal part. That is a seasonal ARIMA to start with. So, for example, if you consider more or less modern, some other modern approach like Orbit model by Uber, that is for forecasting on seasonal time series, and they provide a model and automatic selection procedure to do better than any other models, but they are ahead of this ARIMA model by just a little bit. And sometimes for some time series on M4 competition, even they lose for this one model to start with. So if you have no time to decide for monthly time series, go with that one. It's not always the best, but it's a good candidate, and let's write an equation. So let me decipher the equation. So I have big D equal to 0, big Q equal to 0, big P equal to 1. So I have a small d equal to 1, small p equal to 1, small q equal to 1. Okay, so my yt is a ARIMA 101100, and what does it mean? It means that delta yt, ARIMA process, yeah, delta yt is Arma, seasonal Arma with, so I remove all differences. So I remove that one because I have taken difference. So this will be 0. This is 0 from the start. So I have Arma 1110 seasonal part process. So basically that means if we speak about equation, that means that we have A of L times A seasonal of L times delta yt equals to B of L times B seasonal of L times ut. And I see that this polynomial should have A of L is of power 1, A seasonal of L, sorry, I've missed 12, I have monthly data. And here I also missed 12. Okay, this is a polynomial of the power 1 for B of L, power 0 for BS of L12. And finally, I can provide arbitrary parameters. So it's a custom to have a minus sign in these polynomials. It's a tradition. And it's a custom to have a plus sign in these polynomials. It's a tradition. And so my whole equation will look like 1 minus phi1 times L multiplied by 1 minus phi1 seasonal times L12, because my polynomials should be of power 1 times delta yt equals to B of L should be of power 1. So it has 1 plus, let's say, alpha 1 times L times I have a 0 polynomial, so it is just 1 times ut This is the equation, and how many parameters are estimated. So there are two hidden assumptions. Once again, there are two hidden assumptions. They are not clearly stated in many books, but be careful. We assume that delta yt, it's an assumption. It does not follow from the equation. Once again, equation has infinite number of solutions. These assumptions, they do not follow from the equation. So delta yt is which type process?
It's a stationary process.
Yeah, it's one hidden assumption. You are right that it's a stationary process.
And that it can be expressed with a linear combination of white noises.
Yeah, but this is an assumption.
Yes, yes, yes.
Can be expressed using ut, ut minus 1, ut minus 2, ut minus 3, and so on.
And correctly speaking, to be exactly precise, you misprinted the arrows.
Arrows. What is wrong?
The first one corresponds with AL. The second one, and can you? Yes, corresponds with BL.
Yeah. I agree with you. Yeah, I agree with you. Yeah. Let me. Yeah. I see your point. You are completely right. We need to write. This is for seasonal. Yeah, you're right. Yeah, that's a great point. Yeah, the second part, the first part is for
our process.
Yeah, you're right. The second for MA, the first for seasonal AR. Yeah, you're completely right. I agree. Yeah, that's a good point. Yeah, but it was one, so the equation is okay, but I was wrong with arrows. Yeah. So how many parameters do we have? We have parameters to be estimated. Parameters phi1, phi1 seasonal, alpha 1, and one hidden parameter that is also estimated, sigma squared. So we have, because when, honestly speaking, we are not limiting our process to have normal distribution. That's not a requirement for ARMA process. But when you work with any real statistic software package, then there is one more assumption. Yeah, one more assumption that UT it's not student distribution. It has normal distribution with zero mean and variance sigma squared u. So one more hidden assumption. Usually in software packages, normality is assumed. Okay, and we see that it's a very parsimonious model. We have 4 parameters. Just look at this fact. We have 4 parameters to model 12 seasonal effects. Yeah, that's a great achievement. That's why seasonal ARIMA models are so popular, because we used 4 parameters to model 12 seasonal effects. Instead of 11 dummy variables, we have only 4 parameters. That's a very great achievement. That's why ETS models are so popular. Okay, what else we need to say? I will not go into details and to write down the honest maximum likelihood function, but that's probably would be a great attempt. Okay, let's move on. What we need to tell more. What we need to tell more before going to R. Yeah, we need to talk about automatic selection procedure. Automatic selection procedure. The problem with automatic selection procedure is more or less clear, because we have 20 ETS models. So what is the problem? We have 20 ETS models, and so we just compare them all with using Kayak information criterion. That's a good strategy, and that's what is done. But we have infinite number of seasonal ARIMA models, and basically, even if we limit, so basically we cannot compare them all, because there are infinite number of ARIMA models. But that's not only the problem. Even if we limit, let's say we will limit that P plus Q is less than 5, seasonal P plus seasonal Q is less than 5, D is less than 2, big D is less than 2. If we even we limit ourselves with a small amount of ARIMA models, there is one important theoretical problem. The problem is the following. When you assume, so we have one big problem. The problem is that when you write, let's say, IR1 model, if you have autoregressive model with one leg, then likelihood function, log likelihood function, it's a function that depends, that we have a description for y1, y2, yn. And that's okay. We have a density function for all our observations. And if I consider, let's say ARIMA 110 model, the log likelihood function is a function that depends on delta y2, delta y3, and so on, delta yn. And these log likelihood functions cannot be compared using a Kayak information criterion. They have different number of observations. You have n observations for the first functions. You have n minus 1 observation for the second one function. So AIC cannot be used to compare which is better, R1 or ARIMA 110. And so we need, even if we limit ourselves with models with small number of parameters, even in this case, we cannot just use a Kayak information criterion to compare them all. So the typical so in a standard time series course, it's called Box-Jenkins Methodology. It was a general idea in previous century. It was called Box-Jenkins Methodology, and now it's so modern automatic selection is based on this general idea, Box-Jenkins methodology, that we need to test for unit roots. So the idea is the same. So we may call this idea Box-Jenkins methodology, but nowadays, when we have like big time series forecasting competitions like M4 and now M5, with hundreds of thousands time series to forecast, with many teams competing and so on, now it's like this automatic time series. So so for univariate time series, probably we have reached our limit with. But maybe some subtle tuning can be done. But for univariate time series, I would say that we have almost extracted all possible subtleties from Box-Jenkins methodology, and we have automatic procedure, and it goes like this. So first, KPSS test. Forget about Dickey-Fuller. Dickey-Fuller is never used anymore in the automatic selection procedure. KPSS test, not Dickey-Fuller. So KPSS test just showed that, yeah, it's better for forecasting to use KPSS test. It was fine-tuned on thousands of time series. So basic modern automatic selection looks like this. Modern automatic selection. KPSS test, and using KPSS test, we determine D0, D equal to 1, D equal to 2. Then the second, as far as I remember, is the second, but I'm not sure. Maybe the second is the first. I'm not sure. But as far as I remember, the first check is on non-seasonal difference number. Second check, but it's better. Maybe I need to check. I will write in the chat if I'm mistaken. The second is heuristic. In Box-Jenkins methodology, I think some tests on seasonal unit routes were constructed, but nowadays there is a heuristic, some heuristic indicator of force of seasonal effect, force of seasonal effect. Force of seasonal effect is extracted from STL decomposition. And if this force of seasonal effect is too high, then we take either D equal to 0 or D equal to 1. I'm not sure whether big D equal to 2 is ever used. So this is not even a test. It's just a tuned on many time series idea that this indicator is for force of seasonal effect, and if it's bigger than some threshold, then we take seasonal difference. It's even not a test. There are no statistical assumptions behind this test. So for KPSS test, you may find the description of this test on the web. And then the second step, the number of seasonal differences is determined. And finally, the third step, that for given D small and big D, we estimate models with that depends a little bit on the software, but with small number of parameters in seasonal and non-seasonal part. So automatic selection procedure looks like this. Estimate models with P plus Q less than 5, seasonal P plus seasonal Q less than 5 or equal to A of L times A seasonal of L12 times delta D times delta seasonal big D of YT equals to B of L, B seasonal of L times UT. And basically, best one is chosen by Kayak information criterion. That's a modern interpretation of Box-Jenkins methodology. So Box-Jenkins methodology was an idea that we should compare somehow the models, and it was more or less clear that you cannot use just a Kayak information criterion to compare models with different number of differences, with d equal to 1 or d equal to 0. You cannot use a Kayak information criterion because you have different number of observations in likelihood function. And basically that's all. That's a modern view of Jenkins methodology on one, let's call it slide. It's not a slide, but anyway, I think that doing formulas on slides is a bad idea for teaching math. Okay, the procedure is in general clear. You can find it in, so if you'd like to have a full description, so you should read Hindman. I think it's called something, automatic selection, blah, 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 article, automatic selection. Let me Google Hindman automatic selection. Automatic time series forecasting. It's called automatic time series forecasting.
So do I get it right that we define d small and d capital only once on the first and second step, and then the third step is repeating and repeating until we find the best model?
So we find d and big D and big and small d. They are determined during the first and the second step. The small d is determined by a honest statistical test that is called KPSS test. Then by some heuristic indicator that is the force of seasonal effect. If it's too big, we take seasonal difference. When we have, so we start with YT, there we may go, for example, if D is detected to be 1, we go to delta YT. If, for example, big D is detected to be 1, so we go to delta seasonal of delta YT. So let's call it ZT. And then we use only stationary models for ZT. Okay. So on the step 3, we do not consider different D, small and big D. So when we arrive on the step 3, when we so that's a modern automatic selection procedure. You may always do cross validation. So you are not. So if you have a lot of time, so you are right that you may always use cross validation. So that's okay. You just create a list of models. You divide your time series. You move, as we have done, you move or stretch your train set. Yeah, you estimate one step ahead forecasts, and then you so maybe it's better to write like this. So the first, so you have a first, this is the first training set, and this is the first forecast. Then you have 5 observations in your train set, and you forecast one more observation. When you have 6 observations in your training set, you forecast one more. You do this for all big list of models, and there you can compare models with different D, with D equal to 0 or D equal to 1. Cross-validation does not care. So it's not a Kayak information criterion. So, and you can compare these forecasts using simple mean absolute percentage error or some other indicator, or mean absolute error. Cross-validation is okay to compare models with different D. That's okay. Yeah, you may use cross-validation if it was your question.
No, that was not my question, but I got an answer. Thank you. And I think I have one more. So why do we talk about only Akaike information criterion and not about Schwarz?
Basically, there is a difference that what is the difference between Akaike information criterion and Schwarz information criterion? Schwarz information criterion will select the quasi. So we have some theoretical results that Schwarz information criterion will select the most parsimonious quasi-true model. And we have also theoretical results that a Kayak information criterion, more or less, with some additional assumptions, will select the model selected by cross-validation. So under some, so they are pointed at different things. So that's why we are interested in good forecast. We are not interested in determining. So in many practical applications, you don't care about quasi-true model. You are interested in a good forecast. Okay.
Can I also please ask a question?
Yeah.
In the second step, you told we choose D depending on STL. So is this like a subjective decision, or is there like objective?
No, it's objective automatic. It's automatic selection procedure. No, it's automatic. It's not subjective. So you have a specific way of STL decomposition that is coded. You have a specific indicator force of seasonal effect, and you have a optimize it on thousands of time series. I don't remember the exact border. Like if this force is greater than 0.7 or 0.65, then we decide to use seasonal difference. So no, it's not subjective by any, not at all. It's optimized over thousands of time series procedure. It's automatic. So the word automatic means you do nothing. You just say, oh, I would like automatic ARIMA. Okay, you like automatic ARIMA, the computer will go step 1, step 2, step 3. No, it's not subjective. I have no time to go into details. So if you would like to have details, you need to read the Hindman automatic TS forecasting, and everything is described. Is calculated and so on. But no, that's not subjective. Yeah.
Could you say, please, what is quasi-true model?
What is quasi-true model? You have one more. Probably you have one more. I will today. I'm saying the truth. In many sources, you can read that Bayesian information criterion assumes that the true model is in the model list. That's wrong. That's a common misconception. You have what do we have? You have a true model. You have a reality that has some probability density function for why. So this is true. And you have some models. You have some model set. You have some model set. You have F1 of Y1, Yn, F. Let's say you have K models to compare. You have a lot of models to compare. You have K models to compare. And it may happen that all these models are wrong. So when you are doing Akaike information, when you are using Akaike information criterion or when you are using Bayesian information criterion, all models may be wrong. What we call quasi-true model. You have a concept in information theory in statistics that is called divergence, Kullback-Leibler divergence from reality to model. Yeah, so this is divergence, divergence from reality to model Fi. And this Kullback-Leibler divergence is always non-negative. It will be zero only for model that coincides with reality, with data generating process. But we are sure that our models are, all models are wrong. We are not saying that we have a true model. So we accept that reality is very complex. Reality, there are a lot of interesting things in real life, like you may go to cinema and so on. And in model, you have P, Q, D coefficients to estimate. And so this is always non-negative, this Kullback-Leibler divergence. And what is true model? True model is when you have Fi is just coincide with F true. And what do we mean by quasi-true model? It's a model that is closest Fi with DKL from true to Fi minimized. This is quasi-true model, this is true model. So it may not coincide with true model. If you'd like to read, what should you read if you'd like to understand better these things? Probably you should go to what is a good source? Probably Barnham Anderson. Anderson is a good source. Is a good source if you like to go deeper in this discussion. What is quasi-true model, true model? They have article about AIK and BIC and common misconceptions about Akaike and Bayesian information criterion.
Thank you.
Okay, so now let's do these models in R, and I think that will be all. Okay, I will stop. I will stop sharing here. And I need to start sharing on my.
Professor, sorry.
Yeah.
If I didn't really understand something, should I wait for the end of the lecture to ask?
Yeah, you may ask now.
Oh, okay.
If you need, I can switch back my notes.
Because I was looking at the first part of the lecture when you were teaching us about the wrong assumption that we are doing in the model about the modulus of phi, of the coefficient of an Arma process. And I didn't really understand why is wrong, that assumption, because I understood the difference between equation and process, and that the process is not always an equation, but
the process is never an equation. Equation, yes. The solution of an equation is a process. But
Okay.
equation has many solutions. Processes is never equation. So
Okay.
what's your question?
And my question is, we should never look at the modulus of the coefficient.
No, I haven't said that.
I didn't get that part.
So what's the question? I understand you didn't get which part of what.
Okay,
And what's the question?
if we don't look at the coefficient of the polynomial because it is a wrong assumption for the stationarity of the process, right?
No. I have never said that we do not look at the coefficients. I have said the following, that equation has many. So what are important things? So this slide summarize for ARP process what we need to know. First, if you are searching for a stationary solution that has this special form that does not look into the future, if you are searching for stationary solution of a special form, so if you have two requirements, I'm searching for a stationary solution that does not look into the future, then you may just check whether all lambdas, all roots of characteristic equation are less than 1 by absolute value. That's an old criterion, maybe, that you have been told about in a bachelor course.
Yes.
But my point that this assumption is implicit in many sources. It's almost never. I know only, I think, 2 books when this assumption is clearly stated.
Okay.
Even in a book by Hamilton, the review of Hamilton book was, wow, Hamilton does not write this assumption in this book. The great book on time series by Hamilton. The great
Yes,
book.
I used it actually.
But this assumption is hidden. That's awful.
Yes. Okay, I understood now.
Okay. If you have this requirement, sometimes we have no such requirement, then the criterion is different. If you are just searching for a stationary solution, if you do not require that the solution does not look into the future, then the requirement for roots of characteristic equation is different. That lambdas should not be equal to 1 by absolute value. And even you have the third idea. If you just write an equation and you just write arbitrary initial value, you will get, for sure, you will get a non-stationary solution, because equation of this type has only unique stationary solution, and all other solutions are non-stationary. So if I just by random choice, I will add y0 equals 2, and I will write some initial condition. And then I will get a non-stationary solution. So basically, my ideas are the following. If you are speaking about, I'm checking whether all lambdas are less than 1 by absolute value, you should understand what you are searching, what you are eliminating by this condition. By this condition, by imposing, by saying, I'm solving characteristic equation and I just check whether all lambdas are less than 1 by absolute value. By imposing this condition, you assume that you are searching for a stationary solution, and you also assume this hidden assumption. Okay, so my point is that in many courses, this assumption is not stated explicitly, and that's a bad idea, because you have done linear algebra, you have done probability theory, and in time series course, all theorems are non-rigorous. Why so? Okay, let's stop this, and let's start with share screen. Where is my R Studio? Here it is. I think it's visible. So now I will just copy that part of my past class. I will add this will be class 4. I will use basically the same, so I will save it in documents. R for finance. It will be ARIMA. Okay, I have attached all the packages. I will use the same data set we have used before. So once again, we use production in Australia. So we have here we have time, that is quarterly time series. We have time. Let's consider beer production. Once again, let's GGT as display house production, and I will use beer as my time series. Where is the plot? Here it is. So on the plot, I clearly see that my time series is stationary. On the plot itself, I have in autocorrelations, I have spikes at legs 4, 8, 12, and so on. Here I see that in Q2 and in Q3, on average, the beer production is less than in Q1 and Q4. So clearly, I have seasonal time series. And I can, so let's use some time series models. So let's, so first let's beer. So first let's use approach like train test split. So let me use train test split approach. And let's compare, so our train will be, I filter from house production, oops, not on this one, house production, and my criterion will be, how's the time is named, quarter. Quarter is less than or equal to YMD. Which one is the last observation? Let me check. What is the tail of this time series? Time series tail is 2010. So let's check something like 2009 quarter, I don't know, 601. House test will be quarter is bigger than YMD. Let's look at our house test. So I have only 4. No, I think that's a bad idea. Maybe 01, 01. I have a little bit more observations. 5. But I have 2 years. 2 years. And like that. Yeah, I have 8 observations now. I'm satisfied with this test split. So I have a train test split. I have 8 observations in my test split, and I have what's wrong? I have misprinted T instead of S, and I have 210 observations in my train split. So let's compare some. Let's compare ETS model. Let's compare the model I advise you to use by default, and let's compare automatic ARIMA ARIMA model. Okay, models will be model. We use aus test. Sorry, aus train. We train models. We are not comparing. So first stage, estimate models. Estimate a pool of models. Let's always estimate a simple model. That's a good idea to always estimate a very simple model because it gives you a good benchmark to compare your complex model. So always use a simple model as benchmark. So I will have naive. That will be naive, sorry, seasonal naive because I have seasonal data. Naive for beer. What else? I will have a ETS AAA, like ETS beer error A plus plus what? Plus I will make a smaller plot plus trend A plus season or seasonal, I don't remember, seasonal A. Now with ARIMA, first I would like to say ARIMA 111100. It will be ARIMA so let me recheck the syntax because I don't remember by heart. So what we have here, we have we need to say PDQ and PDQ, big PDQ, and that's okay. So we say that this is beer PDQ 0111 plus PDQ 100.
But wouldn't this model be called ARIMA instead?
Okay, you may add this.
No, I mean for the program. Shouldn't the command be ARIMA?
No. So the idea in Fable package, they are all standardized, and automatic procedure is also called ARIMA. So everything inside. So if I just write ARIMA automatic, it will be ARIMA, and I just need to write beer, and it's automatic procedure I have described from a bird viewpoint. So my description was not very detailed of automatic selection procedure, but you should know you have 3 steps inside. KPSS test to find D small, seasonality force extracted from STL decomposition to check whether you need to use big D 0 or 1, and then a Kayak information criterion to select P, D, and Q. Okay, I may have more models. I may have used the same models, but for logarithm. So if I just consider the same models, but for logarithm, so this is log ETS, log ARIMA, and I will have log beer as, so I may predict log beer. Yeah. Okay, so I may have a lot of models to estimate, so this is just a model table. What's wrong? Valid type PD. It's PDQ. It's not PDF. PDF is just to show you files. Yeah, it's my mistake. It's okay. It's PDQ. It's not PDF. PDF is a good file type, but that has nothing to do with ARIMA. Okay. Any questions?
Not up to this point.
Okay, so let's check all the models. So we have a lot of models. We can even check which models was automatically estimated. Yeah. So you see, when you speak about automatic model, so it has many more parameters than mine. Yeah, it has 1, 1, 2, and so it has 2 more parameters than mine. Let's check the predictive power. You may go into details. For example, if you'd like to extract and have some summary, I think you may go into models. Let's extract, for example, ARIMA automatic, yeah? And let's extract the first component of a list, and you may have some information about residuals, terms, all parameters. Yeah, these are estimated parameters of the model, so you may go into details. But basically, because for ARIMA models, parameters have no useful interpretation, then basically we never look here. So, okay, the coefficient before MA part is this coefficient in polynomial is minus 1.01, but what does it mean? I don't know. Okay, now we may forecast. Forecast, we say forecast. Forecast, we say models, and we say age will be 2 years. The forecasting horizon is 2 years. You can look at the forecasts. Yeah, forecast by naive model. You have point forecast. You have distributional forecast, because hidden assumption is that UT has normal distribution, then forecasts are also normal. You may extract forecast, so it's a honest data frame object, table object. So you can, for example, if I'm interested in filter, how it's called, model equals to, for example, I'm interested in forecast by my ARIMA model. So these are forecast by my ARIMA model. If you'd like to extract a specific model or forecast of a specific model, because we have estimated many models at once. Yeah. So let's compare forecasts. We can say accuracy. Accuracy, we need to supply our forecasts, and we need to supply our data set, I think, aus production. That doesn't mean whether you supply aus production or aus test, because forecasts are done for this period that is included in both time series. And so let's check which one is the best. Let's, for example, select percentage error. Yeah. Let's select, for example, this percentage error. What do I see? I see that my ARIMA is worse than naive forecast. But, yeah, but naive forecast is it's very close here to ETS or automatic ARIMA, and the best one is ETS. In my case, ETS is much better. Sorry, SNAVE. Seasonal naive is better. Yeah, seasonal naive is better, but by mean average percentage error. Which one is better? The ETS model for logarithm of time series is better. Okay. Why do you draw arrows? Yeah, I have. Yeah, this was a mistake. I just remarked in the chat. Yes, Alexei, it was my mistake, but we have discussed about errors in equation. Basically, that's all. What you can do with models, you can estimate them, you can look at the coefficient, and you can forecast. In our case, ETS model is better than ARIMA, but sometimes ARIMA is better. And you see that my ARIMA is worse to automatic. That happens. But anyway, that's a good point to start. My point of start with the worst in this example, but that's okay. That happens. Any questions?
Professor, I have an error because it can't find the function PDQ.
PDQ, just you need to attach all these packages. I have done, so basically what I have done, I have attached, so it should be in Fable package. Fable package is used to estimate all these models.
Yes, I did the same packages, but I don't know why I have this problem.
So basically just restart R. So first thing, restart R, because maybe you have junk in your environment. Maybe you have some other packages attached, and maybe this either you should always write from Z, which so there is a problem. There may be a problem with junk. Why? Because maybe you have some other packages loaded, like forecast package, and it may. So we have discussed in the beginning that you have two traditions in R to work with time series: TS tradition and Sybil tradition. I'm use modern Sybil tradition, and so I use Fable package. But many sources on internet, they use forecast package, and I think that's okay. It will give you the same forecast, but here I may write 1, 2, 3, 4, 5, 6 models in just 6, 7 lines. Yeah, 7 lines, 6 models. Yeah, and it will be a little bit more. And 1 line to forecast them all, and 1 line to evaluate forecast, to evaluate accuracy, and that's great. But with old approach, it can be done, but it will require, let's say, more lines of code. So basically, if you just restart R from scratch, if you will have an empty global environment, if you have installed all these packages, then it should work like a charm. It can. So maybe one possible solution that you either miss, but just restart your R. I will upload my file onto GitHub, and you can just download my file and check whether everything is correctly typed, because I can check your R file now. It takes time. No, I understand that it's you don't like to see errors. I don't like them too. Okay, what are my advices to you? So, okay, I will post today the form and the links to 2 courses to do as a home assignment. What else? In this modern direction, in 2020, there were many R packages in this direction published. So I think once again, you have an old tradition estimate one model. Old tradition, one model to estimate. And packages like forecast is a good forecasting package, but it was written a long time ago when, oh, I have one model, oh, I'm strong, I have estimated one model. And now we have many models to estimate, to choose the best one. And I think new tradition, we have many models to estimate. And you have a lot of packages that, not a lot, but you have Fable, what we have used. But if you are into time series, so for the moment there are, I think, 3 competing time series packages in R that go into that direction. That you have Fable, you have, as far as I remember, it's model time or time model time, I think, and forecast ML. These 3 packages, they go into the same direction. So we have many models. Let's provide a convenient syntax to write many models, and then go. We estimate all of them, we compare all of them, and that saves us life because we have written. So basically, that was written in 5 minutes. So I have started, or maybe 10 minutes. So if you'd like to go, I will not go into details because my part is finished. But if you'd like to work with time series forecasting, so I strongly advise you to not to study only Fable package, but who knows, maybe among these 3 rivals, not Fable will be the best. But by my opinion, for the moment, it's the most developed package among these 3 packages. But they are all in active development, and who knows what will be in the future. It's hard to forecast time series. That's all. If you have any questions, you may ask them now, you may ask them in the chat. Everything is okay. I will try to answer them. My part is finished. I'm happy that at least, how many are you? At least. Oh, you are 10. You are 10 brave participants. Yeah, thank you, 10 brave guys.
Thank you, Professor.
Okay, so I will upload the remaining day. I will upload the remaining script. Follow the part by beautiful, great, and optimistic Dan Fantazzini, and have a nice time.
Sorry, Professor. So for the next times, you suggest us to do the stuff on data camp, right?
The deadline is the
No,
exam.
I mean for what is the next lecture and what we will do next. You suggest us to do complete the R part on data camp.
The art part on datacamp is due on the exam day. So if you'd like to complete it before the art part, that's a great idea, but you are not obliged to do so for
No.
perfect grade.
What's your suggestion? What do you?
Yes, my suggestion is that to be better is, so if you are new to R, then you are right. Practice is a good idea. But if you feel very comfortable in R and if you are short of time now, then the optimal strategy will be to postpone this data camp training.
Okay, I got it. Thank you very much. Thank you for the lecture.
Okay. So it depends on your level a little bit. So for me, it would be boring to do these 2 courses because I can do more or less. Maybe there are some tricks I don't remember, but for me, these 2 courses will be a little bit boring. I have looked through, but that's okay.
All right, I got it. Thank you very much for the lecture.
Okay, bye-bye. If you have any questions, don't be shy. You have a chat, you may, and you use opportunity to ask questions. Don't be shy, because asking questions is to be brave and not to be, that doesn't show that. Okay, have a good evening.
Okay, thanks.
Bye, Professor.
Thank you very much. Goodbye.